Before humanity ever touched the heavens, the dream of spaceflight lived in the minds of visionaries. Figures like Konstantin Tsiolkovsky and Hermann Oberth sketched the future, their equations and illustrations laying the theoretical groundwork for rockets and orbital mechanics. These were not mere fantasies, but the first blueprints for our journey beyond Earth, pioneering visions that would ignite a century of innovation. With theory in place, the age of experimentation began. In the early 20th century, pioneers like Robert Goddard transformed abstract ideas into roaring reality. In quiet fields and remote deserts, they conducted daring rocket experiments, facing failures and breakthroughs with equal determination. Each test launch, a fiery step upwards, pushed the boundaries of what was possible, building the practical foundation for the monumental events that would soon follow. Then, on October 4, 1957, a single event changed the world forever. The launch of Sputnik 1 sent a metallic sphere into orbit, its simple, persistent beeps echoing across the globe. This was more than just a technological achievement. It was a profound statement. The beep, heard round the world, signaled that humanity had officially broken its terrestrial bonds, marking the dawn of a new cosmic age. As Sputnik and other early satellites began to circle our planet, a new era began. Animations and tracking data visualized these man-made moons tracing their paths across the sky. For the first time, objects crafted by human hands were in a stable orbit, serving as silent, circling sentinels. They were the vanguards, proving that we could not only reach space, but also stay there, opening a gateway to unprecedented possibilities. On the ground, a different kind of ballet unfolded in mission control centers. Teams of dedicated engineers became the terrestrial anchors for these celestial travelers, their eyes glued to screens displaying streams of telemetry. From these nerve centers, they monitored every vital sign and sent commands across the vastness of space, guiding the unseen and ensuring each mission's success. The 1960s saw satellites transform from scientific novelties into vital infrastructure. Communication satellites like Telstar began bridging continents, relaying television broadcasts and phone calls across oceans in an instant. This technology collapsed distances, weaving a new fabric of global connection and ushering in an era of instantaneous worldwide communication. Simultaneously, another revolution was taking place, starting in the 1960s and continuing onwards. Weather satellites began to offer a god's eye view of our planet. These eyes in the sky captured sweeping images of Earth's atmospheric patterns, transforming meteorology from a practice of guesswork into a predictive science, saving countless lives by forecasting hurricanes and other severe weather. The next leap forward put a map of the world in everyone's pocket. The Global Positioning System, or GPS, created a constellation of satellites that worked in concert. By triangulating signals from this network, devices on the ground can determine their precise location anywhere on Earth. This system became your global compass, fundamentally changing navigation, logistics, and daily life. As we moved into the late 20th and early 21st centuries, satellites began closing the final frontier of connectivity on Earth. Dishes pointed towards the sky brought the internet to the most remote corners of the globe, connecting the unconnected. This expansion ensured that access to information and digital communication could transcend geographical barriers. Today, the legacy of those early pioneers continues to expand in ways they could only have dreamed of. From high-resolution Earth observation and deep space telescopes like Hubble to critical climate science and the promise of future interplanetary networks, modern satellite technology presents us with endless possibilities. The journey that began with a simple beep now charts the course for our future among the stars.